The need to read, which stirs the very souls of men, is more evident in the present era of progress than ever before. Publishers, bookstores, and newsstands pour out thousands of books, magazines, and newspapers every day to inform, instruct, and amuse. The greater part of these printed materials are made possible by various types of mechanical typesetting. Machines which set type up in lines cast from molten metal, first introduced at the close of the last century, are now the most widely used. Automatic typesetting of complete lines. These are the intertype and linotype machines, which are essentially the same, except only in the vast assortment of models designed to perform the particular needs of various types of special jobs. These composing machines produce type cast in complete lines or slugs. Here is a slug or line of type turned out by these machines. The lines of type, properly arranged, make up the page from which, after inking, the imprint or proof is made. The function of the keyboard composing machine is to produce the essential materials required to prepare a form for printing. But before going into details, let's first get a general view of the whole picture. The operator, depressing the keys, releases matrices from the magazine channels. The matrices are delivered to the assembling elevator in the correct sequence. Here's a close-up of some mats. You can see the letter that has been punched or engraved into which the molten type metal is going to be injected. Let's note particularly the two punched characters, one Roman in style and the other italic. The small lugs and the ears which guide the mats through the various passages and assure the alignment of the letters. Having completed the composition of the line of matrices, the operator sends it over to the casting mechanism. Now the line of matrices is in position for the slug to be cast. Against the opening of this mold, the mats will fit perfectly. Immersed in the crucible, the plunger injects the molten type metal into the mold and against the matrix characters. The metal solidifies, forming letters and symbols in relief. Then the slugs are carried into position to be ejected from the mold and stacked one after another as they are ejected. Meanwhile, the first elevator rises and the second elevator descends to meet it at the transfer channel. The matrices are transferred to the second elevator and raised to the distributor. Here, lifted automatically, one at a time, they are returned to their respective channels in the magazine. These circulating matrices will be used over and over as they are needed for composition. Using this simple sketch of the machine, let's go over the various steps already seen. The mats, responding to the keyboard, are delivered to the assembling elevator. The line of matrices is sent to the casting unit. After the slug has been cast, the matrices are carried by the elevators and transferred for distribution. The operations necessary to produce a slug or line of type are divided into three groups. composition of the matrix line, casting of the slug, distribution of the matrices. Let's now analyze the operations in the first group, composition. Regarding composition, the principal parts are the keyboard, the magazine, the assembler entrance, partitions, the matrix delivery belt, the assembling elevator, and the delivery slide. The keyboard has 90 keys on 6 rows of 15 each. It is divided into 3 sections. The lowercase letters are at the left, uppercase in similar arrangement at the right. At the center, punctuation marks, numbers, and small caps. Every touch of the key releases the required matrix from the magazine. Now we will examine the internal parts of the keyboard activated by one touch of a key to release a matrix from the magazine. They are the key button, the keyboard lever, the key bar, the trigger, the cam frame, the eccentric cam, the rubber roller, the comb, and the key rod. Let's observe how the various pieces react to the key. The key moves the lever to which it is joined. This lifts the key bar. In turn, the key bar activates the trigger, whose function it is to support the frame with its corresponding eccentric cam. The motion of the trigger allows the frame to lower itself so that the cam revolves around the rubber roller, which rotates continuously. The rotation of the cam lifts the end of the frame. This raises the long key rod, which causes the release of the matrix from the magazine. Similarly, we find on every machine corresponding to the keys 90 key rods, which make up the assembled key rod frame, which is situated behind the assembler entrance and brings the keyboard into play with the magazine. Here are the upper ends of the key rods, which rock escapements situated in the magazine, thus allowing the mat to be released. Let's study this operation more closely. The upper end of the rod transmits the movement to a half-moon-shaped device called the escapement. The 2 ends of the escapement are called lugs. Penetrating the magazine, they control the release of the matrices. The mat in the first row is held up solely by the front lug of the escapement. As the key rod lifts, the front lug of the escapement lowers, releasing the first mat. At the same time, the rear lug is lifted and holds the second matrix. As the key rod lowers, the spring returns the escapement to a position of rest, thus allowing the second mat to move forward in the place of the one released an instant before. The same operations are repeated at every touch of a key. The mats that we see come out are arranged in the magazine situated at the upper part of the machine. It rests in a slanted position to facilitate the descent of the mats. It is substantially formed by 2 trapezoidal plates, one below and one above, which, as in our case, can be made of visilite. On the inside of the magazine, there are grooves called channels, which support and guide the circulating matrices. The magazine has 90 channels, corresponding to the 90 keys on the keyboard. Every channel contains a maximum of 21 circulating mats, which are sufficient for the normal requirements of composition. Generally, a mat carries two letters, Roman and italic, or Roman and bold. A magazine contains lowercase letters, Roman and italic, controlled by the left section of the keyboard. The uppercase letters, Roman and italics, controlled by the right section. The small caps, numbers and punctuation marks, controlled by the middle section of the keyboard. In changing to another type, larger or smaller, the magazine must be changed. Similarly, in going to another series or letter design. It is precisely for this reason that machines are built with a capacity of up to 4 movable magazines, any of which can be replaced with others. The pre-selected magazine is brought into working position with the escapements aligned over the key rods. The mats released from the magazines are now directed toward the assembling elevator. Now we'll see the whole operation in slow motion. They are guided in their descent by the assembler entrance partitions, which prevent them from turning out of correct position. The mats fall upon a delivery belt in constant motion, which carries them in correct sequence to the assembling elevator. It takes the same length of time for all mattresses to reach the assembling elevator due to the design of the assembler entrance and matrix delivery belt. Before reaching the assembling elevator, the mats have to pass under a small spring blade called a chute plate, which cuts down its speed so that the rotating star wheel can turn it upright and move it forward against the others in the assembling elevator. At the left, the mats are held upright by a wedge or finger attached to a long horizontal bar called a slide, which travels to the left as fast as the mats arrive. The assembling elevator consists of a front and a back plate. When fastened together, they form a channel in which the mats can assemble. These moving levers control the duplex rail. With this device, the mats can assume 2 positions in the assembling elevator. Mats in the first position, Roman, rest on the fixed lower rail. Mats in the second position, italic or boldface, rest on the movable duplex rail. Hence, each mat can present independently to the mold opening either one of the 2 characters. Here is a line of mattresses which illustrates this principle. For greater convenience, the upper part of the assembling elevator is equipped with a hinged gate. A steel wedge known as a spaceband is assembled between one word and the next. The spacebands are released by the key situated at the left of the keyboard. Because of their dimensions, the spacebands cannot fit into the matrix magazine. Therefore, they are stored in a box above the assembling elevator. The parts for releasing the spaceband are similar to those which release the mattresses from the magazine. The spaceband consists of 2 parts, the tail, the slide, and the small head. Both are wedge-shaped. They are held together by a dovetail construction. The small head is held stationary by the lugs in the grooves of the first elevator, so it remains fixed when the corresponding slide rises. In that manner, the expansion of the spaceband is obtained. Whatever the position of the slide, the outside surfaces of the slide and head are always parallel, due to the construction of the parts. The function of the spaceband is to expand or spread out the line to the predetermined length, thereby increasing the space between words evenly. This is called justification. Having completed the line and checked that the number of spacebands is sufficient for the amount of expansion needed, the operator can send it to be cast. The transfer is carried out by the delivery slide, constantly held under tension by a spring, and held in place by a small lever which will be released by the raised assembling elevator. The delivery slide consists of a short fixed finger and a long moving one. They receive the line and carry it through the transfer channel to the first elevator. At this point, we end the operations of the first group and take up the second, the casting.